What is the best neural network for one-shot detection today? And don't confuse this with zero-shot. Zero-shot is where you prompt in, one-shot when you're showing one sample and your neural network is detecting similar objects. In this video, I will go through a few neural networks that appeared in the last half of the year, because even half of the year this problem was much more complex. And today we have a lot of working solution for this. And I will rate them, and after this video you will know what you can use in your next project and what will be the best solution basically. Why and when do you need one-shot detection? First of all, where your text prompt is not working. And for example, it can be a situation where you need to provide anomaly detection and you just can show one samples of each anomaly, and it's hard to describe this anomaly, and basically it's hard to describe this with prompting. Or some strange image and where you need to find some segment and you even don't know how to describe such situation. And the second, it's where you don't have a lot of training data, and of course visual prompting should work a little bit better than text prompting, and where you don't have a lot of visual data, better to use such neural network with one-shot detection. Half year ago, 1 year ago, usually everyone used one of existing solution. Either it was fine-tuning of some YOLO model with small amount of data and it was not super stable, either it was like Dino v2 embedding correlation or some fine-tuning, and it was a lot of work. But today we just have out-of-the-box solution, so let's go through them. And actually I found 5 interesting neural network. It was a little bit more, but all other neural network, it was either like some parts, like weights were closed, or it was almost no documentation and repository was strange. So I found 5 of them. If you know more good examples here, please write in the comments and maybe I will do another video. When I exclude other networks, I also exclude all models that were more than half year ago, because last time when I tested them, basically they didn't work. For example, a good sample, it's all wheat, and it's even in Hugging Face repository, but it's worked quite bad. So we have 5 neural networks. 2 of them are commercial. It's YOLO E26 and RexOmni. One of them with a little bit strange license, it's Segment Anything Model 3, and 2 of them fully open models. One of them is Pet Dino with Apache license, and the second one, Vision one from WeChat, and they didn't publish license, but previously usually they used MIT or Apache licenses, so I assume it should be the same. Let's go through this list. I want to start with RexOmni because it's the only neural network that actually exists half of a year ago, and they had previous neural network which can solve this task, but previous neural network, it was commercial solution, and RexOmni actually the commercial solution as well, but at least they started research into this specific task. 2 years ago there was a T-Rex neural network, but there was no open sources, or it was API, and actually it was the only company that provides some solution specifically with this domain, like one-shot. Mostly they utilize this with some labeling and anomaly detection. Let's check how it's work. I tested the sample. It's actually not bad. Let me describe a few interesting points. First, for this specific neural network, it's super important to show reference on the same image where you're running your recognition. And a part of neural network, which I will discuss later, also required this, so visual prompt should be on the same image. It may be a problem for one situation, but it should be okay for others. Also, as you can see, I select only the cross, but zeros also detected. And it's one of limitation of such visual prompting, because they don't know where is the limit of what you're selecting. And different neural network will behave a little bit differently. What is important, I could run this on Windows with a new GPU, 5070 Ti. Not all neural network from this video will work there, but this one worked. And the main problem, it's worked surprisingly slow. It was 7.4 seconds per image. I didn't try to optimize this. I assume maybe it's possible. Maybe you need just run this on Ubuntu, but there is what it was. So let's move to the next candidate. The next candidate is Yola E26. And I was a little bit curious here, because I didn't expect that Yola could do this. And when I checked, actually in Yola 26, they also had this mod. They didn't try to marketing this more, but they just have it, and it's pretty nice. It's the fastest neural network among all of which I tested. On my Ubuntu machine with older GPU, it was 50 milliseconds, and on Windows, it was 200 milliseconds with a newer GPU. Maybe it's something because of different layers, different compilation of these layers. I also didn't try to find the problem here. As you can see, the detection level is not so great, but it was the fastest model. Let's move to non-commercial models, and let's start with Segment Anything 3, which has a little bit strange license. On my channel there was Segment Anything 1, Segment Anything 2, they were a great model, and I totally missed with Segment Anything 3 you have this visual prompting. And in reality, it's maybe one of the best solutions in this video. It's not the fastest solution, 350 milliseconds on my Windows machine, but it's possible to extract the template from one image and use it on the different image. And actually the quality of the detection is pretty nice. The main problem here, it's a license. It's not the open source license. It's a license which limited you against a lot of different actions. But theoretically, you can use this open source. I'll discuss this later. And go through open source license. First of all, it's Pet Dino. It's based on grounding Dino. It was on CVPR this year. Actually, it's the latest model among all that I will compare. Metrics pretty nice. Apache license. Really good quality of detection, but maybe it's a more research product. Source code is not well. Also, it's using MMCV, and I were not able to run this on Windows with new GPU, only on Ubuntu. It's not the fastest, 0.6 second on the image, but again, accuracy is pretty nice of the detection. It's working, and it's working open source project with a nice quality. Next one, WeVision 1. This one is from WeChat, but amount of stars on GitHub is just 2 times more than previous solution, and it's 50. But again, it's open source project, which is nice, but it's also MMCV, same problems here, but the code quality is significantly better than Pet Dino, and it's the only neural network that didn't try to detect zeros on my image, but the quality of detection of crosses were lower, so a little bit different setup for this model. Anyway, this model also worked, and maybe among open source, it's more convenient model. So let's do a small summary. You already saw all these videos. You can check what is working better, because this one-shot detection task, it's hard to build a correct comparison between models. It's not a final solution for each time. It's something that you need in between for your first iteration of your solution. And actually, in my opinion, all models that I showed today, they can live in some different projects. But if you a small startup and you are okay with segment anything model license, probably it's the best solution here. If you're a big company but you need to build your own solution with your code and you don't want to pay any money for this and you have enough developers, then of course you need to choose among like Vision One or Dino. And of course, if you like a company which okay to spend some amount of money on specific license and buy a solution, then Yola E26 and of course this RexOmni will be the best solutions for you. But in my opinion, it's super nice progress in the last half of a year, and I'm glad that right now this problem, it's not like fully solved, but you have a good out-of-the-box solution for this problem. So thank you for watching. I'll meet you next time. Bye.